Okay. So today we'll discuss special cases for the transportation problem. The first case is when the transportation problem is unbalanced. So an unbalanced transportation model is one wherein the total demand is not equal to the total supply. So we have two cases here. The first case is when the demand exceeds supply. So that is as shown in table B29. So if you add up all the supply, the total of 150, 175, and 275 is only 600. While if you add up all the demand, so yung 200, 100, and 350, the total is actually 650. So yung demand natin exceeds supply by 50. So what was done here is to add a dummy row. Okay, so nilagyan natin ng dummy row. And ang nilagay nating supply is yung kulang dun sa supply na 50 so that the total demand will now equal the total supply. So if you now add 150, 175, 275, and 50, total na rin niya is 650. Now, if you just added a dummy row, what happens to the per unit transportation cost? Because this is really a non-existent supply. Ang ilalagay mo lang sa cost niya, 000. Okay? So again, when demand is greater than supply, you add a dummy row. Okay? Then allocate. So you put in supply for the dummy row kung ilan yung kulang ng supply natin from the demand. So you subtract the demand and the supply. Whatever is the difference will be the allocation of the dummy supply. The next case is when supply exceeds demand. So ito naman, pag inad mo yung 150, 175, 375, ang total niyan, 700. Pero if you add all the demand, the total is only 600. So kulang ngayon yung demand natin ng 100. So what happens is, before you start the allocation, you add an additional column. So yun yung dummy demand natin. So again, like in the previous case, we put 00 as the per unit cost. Tapos kung ano yung difference between 700 and 600, yun yung ilalagay mong demand nung dummy column. Okay, so yun. So ganun yung ginagawa. Next case is degeneracy. Degeneracy is the case wherein the number of, now in your allocation, using any of the three methods, whether be it Northwest, minimum cell cost method, or Vogel's approximation method, it turned out that the number of cells with content with allocation is not equal to m plus n minus 1. So you count the number of rows, you count the number of columns. The total of the number of rows and columns minus 1 should be the number of cells with allocation. If upon looking at your initial feasible solution and you find that the number of cells with allocation is not equal to m plus n minus 1, then ito yung tinatawag natin na degeneracy. The table is said to be degenerate. Now, this case usually happens if upon allocation, di ba normally pag nag-allocate tayo, so for instance dito sa let's just try to allocate here. So pag nag-allocate tayo, suppose I chose to start with this one, with this cell. Teka lang guys, pakita ko lang. Okay. Let me just put some annotation here. So kunyari maglalagay ako dito sa 1D, sa 1 dummy. So it's a choice between 150 and 100. So I will put 100 here. Kunyari lang 100. 100 naman talaga kasi ang pagpipilian mo, yung demand niya na 100 at yung supply naman ni supply 1. So choosing between 100 and 150, you choose the smaller, so 100. So after putting in 100 here, ang ika-cancel mo yung column. Diba? So kunyari, ang susunod na lalagyan mo naman itong 4. So choosing between 200 and 375 yan. So lalagay mo dito 200. So after putting in 200, ang ika-cancel out mo naman column din. Kasi what you exhausted is the demand of A. Okay? O, suppose ito naman yung lalagyan ko, yung 5. So kung lalagyan ko ng 5, so 375 minus 200 is 175, but B only needs 100, so I will only put in 100 here. So after putting in 100 here, ang ika-cancel out ko column. So nakikita nyo, pag nag-cancel out tayo, isa-isa lang. Okay? Hindi ka nag-cancel ng column at saka ng row. Now, degeneracy happens if, for instance, this is not 375 but 300. So let's just make this 250 so that the total will still be 700. Okay? So nung naglagay ka ng 100 dito, na-cancel out mo yung column, at the same time, na-cancel out mo na rin yung row. If that happens, ang mangyayari dun sa table mo, kukulangin ka ngayon ng cell with contents. Like dito, we will put in 250 here. Tapos dito, lalagyan natin ng 50. And now if you add, you're able to allocate all the supply. So this is 150, na-allocate mo yung 250, na-allocate mo yung 300. Nakuha mo na rin lahat ng demand. Yung demand ng A is 200, the demand of B is 100, the demand of C is 300, and the demand of the dummy is 100. But if you count the number of cells with content, there are only 5. Eh, ang number of columns natin, 4. Ang number ng rows natin, 3. So pag nag-minus 1 ka, dapat 6 ang may laman. So why did that happen? Kasi nga when we allocated 100 to cell 3B, we canceled out the second column and at the same time we canceled out the third row. So to solve that degeneracy, kung saan nangyari yung simultaneous canceling of a row and a column, dun tayo maglalagay ng isang zero entry. So that means we either put a zero entry in 1B, 2B, 3C, or in the dummy. Okay? So dito na lang natin lagyan siya ng 0. So considered na occupied itong cell na to. So now we have 6 cells with content. It's just that this cell now has an allocation of 0. But in the stepping stone method, in the MODI method, you will treat cell 3D as a cell with allocation. Nakuha, guys? Okay, so that's the case of degeneracy. Again, it happens when after your initial allocation, you canceled out both a column and a row. So if that happens, assign a zero entry in one of the cells that you canceled. Okay, so para ang total mo, the number of occupied cells or number of cells with allocation will be equal to the number of rows plus the number of columns minus 1. Okay, without this 0 here, guys, you will not be able to solve all the mu's and all the v's using MODI, or there will be times when you cannot go around. So kunyari, kung wala tong 0 na to, ito lang so kung wala yung 0, just to illustrate, guys, if you use the stepping stone method, there is no way that you will be able to trace a path. Okay, so try lang natin. Magte-trace tayo ng path sa 1A. Without the 0, so horizontally, you will move to this cell. Tapos vertical ka dyan. Tapos wala na, stuck ka na. Kasi wala nang laman to. Diba? So hindi ka makaka-trace ng close path. But with the 0 here, meron na. Kasi pupunta ka dito, bababa ka dyan, punta ka dito, and tataas ka doon. Because you are now treating 3D as a cell with content. Okay, so yun yung importance of having the number of cells with allocation equal to the number of rows plus the number of columns minus 1. If that will not be satisfied, there will be times that in trying to trace a closed path for unoccupied cells, wala kang matitrace na closed path. So you have to be able to monitor whether the number of cells that you have allocated some units to is equal to the number of rows plus the number of columns minus 1. Okay? So let's move on. Okay. Let me just clear all the drawings. Another case, guys, is there are times when there are some routes that are not feasible o sabi nila prohibited. Now for prohibited routes, ang ginagawa naglalagay ng M. Okay, but for us, we will not put M, guys. Ang gagawin natin, similar to what we did in the in the linear programming method, yung M natin will be, okay, so let me just emphasize this. So our M will be the lowest power of 10. Okay, higher than, okay, so the lowest power of 10 higher than the highest per unit transportation cost. So, ibig sabihin, kung titingnan natin tong table na to, okay. So, dito guys, halimbawa, ito ay gagawin nating ano, okay. So, lagyan ko ng stamp to. Yan. So, kunyari, prohibited cell na yan. Okay? So, ibig sabihin, we do not want anything to appear in cell 1C. So, maglalagay tayo ng M dyan. What will be the value of M in this case? Oh, let's not make that as the prohibited cell. Let's just use this as the prohibited cell. O, prohibited daw to. Ayaw nila ng may laman dyan. Okay, wait lang. So, prohibited yan. Okay.
100 po ba, ma'am?
100. So, bakit 100? Kasi kung titignan natin, yung mga per unit, ang highest 12. Diba? Kaya ang ilalagay natin dito, to ensure that this cell will not have any allocation, ang ilalagay mo dyan, 100. Okay, guys? Nakuha niyo ba? So, dito ilalagay natin dyan. In place of the 100, ang ilalagay natin ay, in place of M, ang ilalagay natin dyan, 100. Okay? So, kung wala yung 7 na yun. Nakuha niyo, guys? So, kaya ginagawa yun para hindi na lang M. Kasi otherwise, in your computation for improvement, may M. And it might be a little hard for you to determine whether the table is already optimum kasi may variable. So, para matanggal natin yung variable, lalagyan natin ito ng 100. Nakuha nyo, guys? E paano kung dito tayo magkakaroon ng prohibited cell? Let's see. Parehas yan eh, no? Parehas din. Pare-parehas ba ng example dito? Okay, so let's just look at the exercises. Meron na ako nakita dito may M eh. Assignment na to eh. Kukuha nyo ba, guys? Ha?
Paano po ulit malaman kung saan yung prohibited na cell?
Sasabihin kung saan yung prohibited.
Sasabihin naman.
Katulad dito, may nakita ko dito na sabi may prohibited eh. Parang number 11 ata yun. Tingnan ko lang nga, guys. I think it's in number 11. Ayan. Ay, hindi. Ayan, ito. Clear all drawings. Kita nyo, guys, number 11. Coal is mined and processed at the following 4 mines, blah, blah, blah. So this is actually unbalanced. Kasi the total supply is 280, while the total demand is 330. So meron tayong dami dito. And also, look at the statement. Because of railroad construction, shipments are now prohibited from Cabin Creek to Richmond. So yung Cabin Creek natin sa A yun, ang Richmond natin sa 1. So dati may caution na 5. So tatanggalin mo raw yung 5 na yan. Kasi prohibited na siya. Okay? So prohibited na siya. So hindi na siya 5. So ang sabi sa libro, lalagyan natin yan ng M. Pero para hindi na lang M, anong ilalagay natin dyan? Para sure na hindi ka magkakaroon ng allocation dyan. Dapat mas mataas siya sa lahat. And we'll just choose a power of 10. What power of 10 should replace the $5 here? To ensure that there will be no allocation to A3. Well, look at the per unit cost, guys. 7, 10, 12, 9, 4, 7, 3, 11, 9, 5, 7. So how many should be allocated?
100 din po, ma'am.
100 din. Diba? Kasi ang highest natin, 12. So ang lowest power of 10 higher than 12 is 100. Nakuha niya? Okay na tayo. So yun. So those are the three special. Okay. Now here is another special linear programming problem, and it's very similar to transportation model. It is actually considered as a special form of transportation problem. So dito, the problem is not simply transporting goods from one source to several destinations, but rather the problem is often on the assignment. That's why it's called assignment. As in table B34, the case here is that we have an Atlantic Coast Conference for basketball games. So the basketball games will be conducted in Raleigh, Atlanta, Durham, and Clemson. Okay, so of course, if there's a basketball game, there should be an official. So there should be an official who will oversee the conduct of the basketball games. So meron tayong 4 officials, si A, B, C, D. So ang problem natin dito is whose official will be sent in Raleigh, who will be sent to Atlanta, who will be sent to Durham, and who will be sent to Clemson. Okay? So yun ang tanong. Si A, saan siya papadala? Will he be sent in Raleigh, Atlanta, Durham, or Clemson? Ang target dito is minimize the total distance traveled by the official. So yun, kaya siya tinawag na assignment. It's basically a problem where your intention is to assign officials to game sites, to assign personnel to projects, to assign persons to machines. So assignment talaga siya. Now, how do you solve transportation problem? You solve a transportation problem by first coming up with an opportunity cost table. So sa opportunity cost table, ang first step dyan is to look for the lowest cost per row. Like dito, if you look at the official A, saan ba siya pinakamalapit? Sa Raleigh, sa Atlanta, sa Durham, or sa Clemson? Sa Atlanta, di ba? So lowest kasi yung distance traveled niya sa Atlanta. So ipaprioritize mo ngayon si A sa Atlanta. So you will subtract 90 to all the entries in row A. Sa row B, nearest din siya sa Atlanta. So you will subtract 70 to all the entries in B. You do the same for the succeeding rows. And this is what will happen. Ang problema, lahat sila, pinakamalapit sila sa Atlanta. So hindi pa rin na-solve yung problema mo. So ito ngayon yung mga natira. When you subtracted, di ba ito, sinubtract mo na yung 90 sa 210 and so on. When you subtracted, ito pa yung mga natirang distance traveled. The next step will be to find the lowest naman per column. So of course, yung column natin for Atlanta will stay at 000, but the columns for Raleigh, Durham, and Clemson, hindi pa siya yung lowest, hindi 0 yung lowest. So for instance, for Raleigh, the lowest is 30. So the next step would be to subtract 30 from all the entries in column A. Dito naman, 35. Ima-minus mo yung 35 sa lahat ng entries sa Durham. Dito ang lowest natin is 55. Isusubtract mo yung 55 from all the entries in Clemson. And this is what will happen. Okay? So, after computing the opportunity loss table, the next step would be to try to draw a line that will cover all the zeros. Okay? We will try to cover all the zeros using the minimum number of lines and see how many lines will be needed. Okay? Now, if the minimum number of lines that will cover all the zeros is already equal to the number of rows or column, then you have the optimal assignment. So that means you can already assign one-to-one. So an official will be assigned uniquely to a game site. Okay, so try natin. So of course, we will prioritize the rows or columns where you will hit many zeros. So of course, ang uunahin natin yung column ni Atlanta. So we're able to cover all the zeros, 4 zeros with just 1 stroke. So magkakaiba na tayo na kasi depende kung ilang stroke. Ako, I would opt to draw I would opt to draw a horizontal line kasi it would hit Okay, yan. Dapat straight, pero okay na yan. So meron pa tayong isang zero na hindi nako-cover. So we either draw a horizontal line or a vertical line here. So I guess I'll just use a horizontal line. Okay. Ay, hindi. Vertical na lang. Ang gusto nyo, vertical, horizontal. It doesn't matter really. Well, I guess I'll just use, mas madaling mag-drawing ng vertical. So how many lines are needed to cover all the zeros? Tatlo lang. So this table is not yet optimal. So dahil hindi pa siya optimal, ang gagawin mo ngayon, hahanapin mo what is the lowest among the uncovered cost. So 105, 15, 55, 15, 75, and 10. Ang lowest dyan is 10. Ngayon, itong 10 na to will be subtracted from all the uncovered cells. It will be added to all the intersections. So, ibig sabihin itong 0 na to, magiging 10 na yan. Itong 5 na to, magiging 50 na yan. The rest of the covered cell will stay as is. But for the uncovered cell, lahat sila mababawasan ng 10. So, this will now have 95. Ito magiging 5. This will be 45. This will be 10. I mean 5. So this will be 65 and this will be 0. So nadagdagan tayo ng 0, di ba? Nabawasan din tayo ng isang 0 kasi ito magiging 10 na. So again, we'll try to cover all the zeros. Okay, so this time we'll use, let me erase some of the lines again. Okay lang ba kayo, guys? Nakuha nyo ba? So we'll try to cover all the zeros again. Okay, so dito, I would still want a vertical line through Atlanta kasi 3 0 pa rin yung mahihit mo dun. Eh. So 1. So this has 2 zeros. So I'll try to hit, I'll try to use a horizontal line for D. Ay, sorry. Okay. Kaya naman pala lumili ko, nakakaliwa naman pala yung ano ko. Yan. So ito, 0 na rin to, di ba? Ito din 0. Okay, so pwede nating isa pa rin. Okay, so ito na lang yung covered natin. Still, we were able to use 3 lines. So it's enough to use 3 lines to cover all the zeros. So we just repeat the process. So among the uncovered cells, ito uncovered na rin siya. Diba? What is the lowest? 5. Okay, so this will change again. This will now be 0. This will be 90. This will be 45. This will be 20. But this will be 0 also. This 65 is now 60. So nadagdagan tayo. Tapos itong 0 na to, magiging ano na to? This is
50
not
po
ano.
yung 65.
Oo, itong 0 na to magiging 5. Tama? Ito magiging, ano ba to? 10? 15 na siya, di ba? So this is not an intersection, di ba? So 15 pa rin siya. This will still be 0. Now this time, if you try to cover all the zeros, it will need 4 lines to cover all the zeros. Okay, let me show you an example. Medyo magulo na yan. Okay, clear all the drawings. So, medyo magulo yung ano natin. Can you see the Excel file, guys? Guys, can you see the Excel file now?
Yes, ma'am.
Kita po.
Kita na. Yan. Ito yung sa assignment natin. Yan. Teka, burahin ko lang din to. So, ito yung table 1 yan. So, kinuha muna yung lowest per row. Okay. So, 9. Okay. So, yan. So, nag-minus tayo ng 9 dito. Bakit 0 to? Ah, hindi. Merong naka-hide na rows. Let me just unhide the rows. Okay, so ito yung table 1 natin. Nag-minus tayo ng 9 sa row 1. Nag-minus tayo ng 5 sa row 1. Sa row 2. We subtracted 11 from all the entries in row 3. We subtracted 8 from all the entries in row 4. So ito yung mga 0, 0. Then we look for the lowest per column. So ito 0, so as is siya. Ang lowest dito 3, so we subtracted 3 from all the entries here. Ito 0, so as is, And then we try to cover all the zeros. Pag nag-cover tayo ng zeros dito, guys, we will need Okay, let me just use a line. So, okay, I'll try to use one line to cover row 1. Okay. So, yan. Tapos, I need to cover 4 more lines. So, I'll use another line to cover row 3. Okay. Pero meron pa akong dalawang zero. So, I'll use another line to cover column A. So, I'm able to cover all the zeros by using 3 lines. So, hindi pa siya optimal. So, what is the lowest among the uncovered cell? 1. So, ang nangyari, itong 1 na to, okay, magiging 2 na siya. Itong 1 na to, magiging 2 na siya. All the other covered cells remained as is. Tapos, yung mga uncovered, nag-minus tayo ng 2. So, yung 2 dito naging 1, yung 2 na to naging 1, yung 3 naging 2. Yung 4 naging 3, yung 3 naging 2, and yung 1 naging 0. So, ito na yung mga zeros natin. Now, this time, we'll try to cover all the zeros again. So, I'll use one horizontal line to cover row 1. Another a vertical line to cover column D. Okay. But I need to cover two more zeros. Magkasaliwa. So that means I need to use 2 vertical lines or 2 horizontal lines. So there's no way I will be able to cover all the zeros using 3 lines. I really need to use 4 lines, di ba? So ibig sabihin, optimal na to kasi we have 4 rows and 4 columns. Ngayon, ang question, ano na yung assignment natin? Look at where the zeros are. So ibig sabihin, si 1 can be assigned to B or C. Si 2 can be assigned to A. Oh, so si 2 sa A lang. So fix mo na siya. Okay? So sa A na siya. Okay? So that means 2 will be assigned to A. Sure ka na dyan? Kasi dun lang naman siya pwedeng i-assign eh. So 2 will be assigned to A. Okay? Tapos si 4, sa D lang siya. So 4 will be assigned to D. Now, if you have already assigned 4 to D, we can no longer assign 3 to D. So that means ang option mo na lang kay 3 ay sa B. Diba? So, dahil may naka-assign na sa B, si 3 yon, you can no longer assign 1 to B. So that means you will need to assign 1 to C. So ito na yung assignment natin. 1 will be assigned to C, 2 to A, 3 to B, and 4 to D. Tapos, what is the total cost of assignment? You go back to the original table. Okay? So, pupunta ka ulit sa original table. So, dun sa original table mo, magkano ba yung 1 to C? So, 1 will be assigned to C, 9 yon. 2 will be assigned to A, 5 yon. 3 will be assigned to B, so that's 14. And 4 will be assigned to D, 9. So, ang total cost natin will be 9 plus 5 plus 14 plus 9. So, yun yung total cost for assignment. If these are costa, kung distances yon, you just add 9, 5, 14, and 9. And that will be the lowest distance that the officials will need to travel to the game sites. Okay? Question, guys?